Okay, the first thing here is that the three bodies will move with same acceleration because they are tied through a string which are non-stretchable. So the acceleration of the entire system will be the net force on the system upon total mass. This will be 2.5 meter per second square. Now to find the tension, if we are calling this as T1, to find the tension here, we'll take the 10 kg and 2 kg block as the system, and tension becomes, this T1 becomes external force for that, and this T2 becomes internal force. So the net external force for this system is T1. This should be equal to mass into acceleration. Mass is 12 and acceleration will be the same. So from here you'll get T1 as 30 Newton. And similarly to find T2, you take 10 kg block as your system. T2 is the only external force, that should be equal to mass into acceleration. This will give you 25 Newton. That's how simply you solve these kind of simple problems. Okay. Now let's solve an relatively interesting problem. This is 30 degree, suppose this is 60 degree, there's a block M1, M2. Suppose the mass of M2 is given as 1 kg and the mass of M1 is given as √3 kg. Now you have been asked, what is the acceleration with which the block string system will move? This wedge is fixed on ground. This is not moving. Though it shouldn't be a problem for you to find the acceleration of this because this question is in the same line as the one we have been doing up till now. So it shouldn't take much effort and much time. Get your answer quickly with what acceleration M1 and M2 will move. Okay, to solve this, suppose I'm assuming that M1 is coming downward. You can assume the other way around as well, not going to make any difference in the answer as we have discussed. If M1 is coming downward, the downward force is mg sine theta. Not a problem to identify that. So the mass is given as √3 mg sine theta. That is half. Is the force downward, and the upward force would be tension. This is the net external force in downward direction, and the acceleration would be, and this net external force should be equal to mass into acceleration. Okay, and for this one, if M1 is coming down, then M2 will go up, and the force pulling it upward is tension. The tension would be the same, it's the same string, there's no knot, there's no joint in between. So both the tension at both the ends would be the same. This tension is upward, the downward force would be mg sine 60 degree. Mass is given as 1. This should be equal to mass into acceleration. That's it. Now you have to eliminate A. If we add these two equations, then what we have is these two get cancelled out, and you have 0 is equal to √3 plus 1a. This shows that acceleration will be 0. That means the system is stationary, it is not moving at all. The acceleration of both m1 and m2 turns out to be 0. Okay, so it is in balanced static equilibrium condition. Fine. Now the question, if suppose, is what is the force which the string is applying on the pulley? So the force that the string is applying on the pulley, that would depend on the tension, and it is if it is an equilibrium condition, so tension will be equal to mg sine 60 degree. That would be this 5√3, and the tension applied on the string is at an angle of 90 degree. This angle is 90 degree, right? So you know what will be the net resultant force. That would be 5√6. 5√6 Newton of force will be applied by the string on the pulley. Okay. So very similar to this, let me give you another problem. Suppose this is of 1 kg, or suppose this is of 10 kg. Okay, this is 30 degree and this is 60 degree. Now the question is, with what acceleration will the 10 kg block moving? So this is straightforward. Just the way we did the previous question, you have to do it in exactly the same manner. Shouldn't take much time for you to find the acceleration of 10 kg block. Find the acceleration of 10 kg block. The acceleration of this 10 kg block would be 14 meter per second square, I guess, down the plane. You have to specify direction as well because acceleration is a vector quantity. Fine, you got your answer? Very, very good. Now let's see how you have to do it. You just have to write the Newton's second law of motion. The equation for the Newton's second law of motion. That's it. So let us assume, oh no, it won't be it will be 14 meter per second square up the plane, not down the plane. It will be up the plane. Now let us assume that it is going up the plane to write the equation. So the force which is up the plane is 200 Newton because the external force applied is 200 Newton, and that will be the same as tension. So 200 Newton of tension is pulling it upward. This 10 Newton is pulling it downward, and there will be some component of mg as well. Mg sine 30 degree, that will be 50. That is also pulling it downward. This is the net external force in upward direction, up the plane. This should be equal to mass into acceleration. So from here you will get acceleration as 14 meter per second square up the plane. Okay, that's simple.